What if we are asked to calculate the mass of a substance in grams? We will need to rearrange the equation mass over the molar mass to be the mass of the substance in grams is equal to the number of moles multiplied by the molar mass in grams per mole. Let's apply the formula in this example. Use these relative atomic mass values: iron 55.8, hydrogen 1, oxygen 16, to calculate the mass of 5 moles of iron 2 hydroxide, FeOH by 2. From the formula, you can see that we have 1 iron atom, 2 oxygen atoms, and 2 hydrogen atoms. First, we need to calculate the molar mass of iron 2 hydroxide, which is equal to 55.8 for iron plus 16 for oxygen multiplied by 2 because we have 2 oxygen atoms, plus 1 multiplied by 2 because we have 2 hydrogen atoms as well, equal to 89.8 grams per mole. The mass of 5 moles of iron 2 hydroxide is equal to the number of moles multiplied by the molar mass of iron 2 hydroxide, equal to 5 multiplied by 89.8 equal to 449 grams. So 5 moles of iron 2 hydroxide contain 449 grams of iron 2 hydroxide. Notice we can verify our answer by looking at the units. Mole multiplied by gram per mole gives us the grams, which is the desired unit. For an effective chemical reaction, we need to know the stoichiometry of the chemical equation or the ratio of moles of the reactants and the products. For example, this equation shows us the stoichiometry as a large number written beside the chemical formula. From the equation, you can see that 1 mole of iron 3 oxide reacts with 3 moles of carbon monoxide to form 2 moles of iron and 3 moles of carbon dioxide. These numbers 1, 3, 2, and 3 are called stoichiometric numbers.